All right, now let's look at the way to represent the subatomic particles that we just talked about. This is called the AZ notation, and it is a way to symbolize an element that gives all the information that you need in terms of how many subatomic particles there are of each kind. So the AZ notation has kind of three different parts to it. The center part is the X, and so you see here this X is your atomic symbol. Obviously not every element is represented by X. In fact, there is no element represented by X. X is just a general letter to denote the atomic symbol. Now, where would you find the atomic symbol? The atomic symbol is a 1 or 2 letter abbreviation that stands for a specific element on the periodic table. And so if you're looking at the periodic table, the 2-letter symbol is always in the center of each box. I'm going to scroll forward a little bit. Here's a periodic table of elements. So for hydrogen, for example, if we're zooming in, hydrogen would be the capital letter H as your X, right? That's what you would replace X with. If you have lithium, you would replace it with Li. If you have beryllium, you would replace X with Be. Notice on the periodic table, I just want to make a note that the first letter is always capitalized and the second letter is always lowercase. So if you have a second letter in your chemical symbol or atomic symbol, it is always lowercase. That is something to keep in mind. The first letter is always uppercase. So this is where you would find the atomic symbol for your AZ notation. Now, the other part of the AZ notation is obviously your A and your Z, which is in your upper left and lower left-hand corner. So here you have the A. The A is the mass number, and your Z is your atomic number. Okay? The atomic number is the number found on the periodic table above the atomic symbol. And they match the number of protons in the nucleus. So again, let's slide over to the periodic table. The periodic table is here. If we again zoom in, okay, you see the number here in the top right here, 1 for hydrogen. That is the number of protons, and it is also what we call the atomic number. Okay, the atomic number is often represented as the variable z, so it'll say z equals 1, for example, hydrogen, right? There are lots of atomic numbers. So 3 would be for lithium, 4 would be for beryllium. And if you take a note and zoom out a little bit of the periodic table, you will notice that the periodic table is in numerical order, like it goes reading from left to right, 1, 2, 3, 4, 5, 6, all the way through. So the atomic numbers are arranged in sequential order to make it easy for you to find a specific element if you know the number of protons. Okay. The last little bit is the mass number. The mass number is the total number of protons and neutrons in the nucleus. It is not shown on the periodic table. You really do need to figure out the mass number based on your A and your Z. So really, if you're looking at, say, for example, carbon is in box number 12. So if you're looking at it, it'll say that it has 6. So it'll say 6. And then it'll say C, and then it'll say carbon, if you look in box number 6. So 6 here is your Z. It is also the number of protons because the Z is the atomic number, which tells you the number of protons. That's why you have 6p here in the center in terms of this drawing, okay? Now, normally with the AZ notation, it'll read 612. Well, what does this 12 tell you? 12 tells you the mass. All right, so if you want to find out the number of neutrons, it's always going to be the mass subtract the number of protons, right? Because the total mass is protons plus neutrons, so the number of neutrons has to be equal to the mass minus the protons. So for carbon, it's going to be 12 minus 6. 12 is in the top left-hand corner there, that's the mass. 6 is the atomic number or the number of protons. So you end up with 6 neutrons, right? And that's why if you look in your little picture here, it says 6N0 or 6 neutrons, okay? So really, if we look in the lower right-hand corner here, it says, but how many neutrons? Okay, and it says here, note that information about the neutrons is not provided on the periodic table or in the AZ notation, but it can be calculated from the AZ notation because really it's always the mass minus Z, or the number of protons, right? Hopefully that kind of gives you a good idea of how to parse that information. In the next video, we're going to go over how to do these problems. If you want, you can take a moment and see if you can do some of these problems based on what we've already covered. But if not, you can navigate to the next video and I'll work through these problems.